Let us do some calculations with scientific notation. Let's start with multiplication. So this is a 1.2 times 10 to the power. The comma moved from here to here. We are reducing a very large number, so it moved 1, 2, 3 positions. And this one, the comma moved from here to here to make it a scientific notation, so it will be 3 times 10 to the power. We are dealing with a small number, so this will be position 1, 2. So for small numbers, it will be a minus 2, the decimal numbers. Now 1.2 times 3, you multiply numbers with numbers and base 10 with base 10. So 1.2 times 3, that's a 3.6 times 10 to the power. These ones are common, so this is a 3 plus a minus 2. So this is the same as 3.6 times 10 to the power 1. 3.6 times 10 to the power 1. So that's your answer in scientific notation, or you can expand it. 3.6 times 10 to the power 1, it's a 36. So we are just showing how you can apply scientific notation. So this is a 3, the comma must move from here to here. It moved 1, 2, 3 positions. 3 times 10 to the power 3 times, the comma must move from here to here to make it a scientific notation. 5 times 10 to the power 1, 2, 3, 4. From this point to this point, there are 4 positions. So 3 times 5, that's a 15, times 10 to the power 3 plus 4, because the bases are the same. This will be 15 times 10 to the power 7. Now, this is 1.5 times 10 to the power 1 times 10 to the power 7. This will be 1.5 times 10 to the power 1 plus 7. So our final answer is 1.5 times 10 to the power 8. So let us see if this will help in division. This will be 1.5 times 10 to the power. The comma moved from here to here to make it scientific notation. Between this point and this point, there are 1, 2, 3, 4 numbers. Divided by the comma moved from here to here to make it a scientific notation. This will be 3 times 10 to the power 1, 2, 3. Now 1.5 divided by 3, that's 0.5 times 10 to the power. These are the same base, so this will be 4 minus 3. So this will be 0.5 times 10 to the power 1. So this will simplify just to a 5. Or else in scientific notation, this will be 5 times 10 to the power negative 1 times 10 to the power 1. These powers are the same, so they add, you get a 0. This will be 5 times 10 to the power 0. It's a 5 or 5 times 10 to the power 0. Now, there's a concept I want to introduce. You don't need to convert to the perfect scientific notation when you're doing the calculations. Why am I introducing this? This is what you're going to be using when you're doing addition and subtraction. You need just to put this into stuff which you can use. For example, 16 and 4 can divide each other, so it will make life easier for me. So I want to make this a 16. So the comma will move this way to make it a 16. So this will be a 16 times 10 to the power minus 1. We have treated this as a decimal as we move the comma this way. Look, at the decimal we move the comma this way. So divided by, let's move the comma this way to this position. It will move 1, 2, 3 points. So this will be 4 times 10 to the power minus 3. Now we can say 16 divided by 4, that's a 4. This divided by this, the bases are the same, so the powers will subtract each other. So this would be 4 times 10 to the power minus 1 plus a 3. And this is a 4 times 10 to the power 2, or it's a 400. Okay, let's finish up this session with addition and subtraction. So the powers of 10 should be made the same first if you want to do addition and subtraction. Why? Because we need to factor out whatever we'll be dealing with. Now 4,000 plus 2,500, we know that this is 6,500. 4,000 plus 500, we know that this is 4,500. But we need to see how we can use scientific notation, because it's the concept which we need to get used to. So this is 4 times 10 to the power 3. From this comma point to this, the 4,000 is 1, 2, 3, 4 times 10 to the power 3. Plus, we move the comma from here to here to make it 2.5 times 10 to the power. It moved 3 positions. Now, you see, the powers of 10 are now the same, so you can factor out 10 to the power 3 outside. We removed 10 to the power 3, which is common, and we are left with 4 plus 2.5. So 10 to the power 3 times 6.5. This will simplify to 6.5 times 10 to the power 3. Let's do it here again. This is 4 times 10 to the power 3 plus. Now, this will be to the power 2. This will be 5 times 10 to the power 2. But I said we need to make sure everything is to the power 3, or everything is to the power 2. In whatever case, just make sure these two are the same. So let me just show one way here. So 4 times 10 to the power 3 plus, let us make this to the power 3. So moved 1, 2, we now have a 5. 3, we now have 3 positions, so this will be 0.5 times 10 to the power 3. Now we all have the 10 to the power 3, so this will be 10 to the power 3, 4 plus 0.5, and this will be 10 to the power 3, 4 plus 0.5, that's 4.5, so this will be 4.5 times 10 to the power 3. Now let us finish with subtraction. We know that 0.4 minus 0.01 is 0.39, but let us do that in scientific notation. This, we move the comma 2 points, so this is a 4 times 10 to the power minus 2, minus this 1, 2, 3. From this position to this position is 1, 2, 3. So this is 1 times 10 to the power minus 3. Now, this is what we have. As we said in the last time, there are 2 ways in which you can do it. It doesn't matter which way you do it. I'm just showing you both cases. So in the first case, we can convert both powers to minus 2, or in the second case, we'll convert both powers to minus 3. The idea is that when you're adding and subtracting, the powers of 10 are supposed to look the same. Okay, so let us start with case 1. Let's convert everything to power minus 2. So this one is already in power minus 2, so it's 4 times 10 to the power minus 2 minus this one. Let us convert it to power minus 2. So this was 1, 2, 3. We only need 2. So this will be 1, 2. Position 1, position 2. So this will be 0.1 times 10 to the power minus 2. This is how we convert this to the power minus 2. So now we can calculate. Since 10 to the power minus 2 is common, we take it outside. Then we are left with 4 minus 0.1. And 10 to the power 2, 4 minus 0.1, that's 3.9. So our final answer is 3.9 times 10 to the power minus 2. Let's convert everything to 10 to the power minus 3. So this one, 1, 2, we need it to be a minus 3, so we add an extra 0 there. So it will be 0.04. Then we check from this position, 1, 2, 3. So we will have a 40 times 10 to the power minus 2, post comma will be here, minus, sorry, to the power minus 3. From 1, 2, 3, it moved to 3 positions, minus, this is already in the form of minus 3. So 10 to the power minus 3 is common, we put it outside, you are left with 40 minus 1. 10 to the power minus 3, 40 minus 1, that's a 30. Minus 1, that's a 39. Sorry, got distracted there. 40 minus 1, that's a 39. So we are left with 39 times 10 to the power minus 3. 39 is 3.9 times 10 to the power 1. That's 39 times 10 to the power minus 3. You'll be left with 3.9. You add the powers, times 10 to the power 1 plus a minus 3. You are left 3.9 times 10 to the power minus 2.